So I want to take just a few minutes before I send you home and talk a little bit about what our summer annual options are. Kelly, can you open this for me? I can't even work a bottle of water, and you're supposed to listen to me. I've got, as my dad would say, I've got too much education. I had to turn in all my common sense. Oh, look, you can tell she's a PhD candidate. She can't get it off either. Anyways, I want to talk a little bit about what some of our summer annual options are for following these small. Naturally, some of our options will be going back to grain crops. Soybeans and corn would certainly be an option. And I want to talk about some of the summer annual options. And the neatest part of this presentation will come towards the end, and it's an economic analysis of what these summer annuals can return in a very short period of time when we wean calves from a fall calving cow onto these summer annuals in June. My contact information's on here, but I always encourage you to use your extension agents. We've got some great extension agents in this part of the state, so make sure you utilize them as much as you possibly can. So again, this is the issue that we have. Our forage base in Kentucky, in other transition zone states like Virginia and Missouri and West Virginia, North Carolina, is a tall fescue base. And we get this typical growth curve. We get a hump of growth in the spring. We get a secondary hump in the fall when things start to cool off. But in the summertime, our cool season grass growth is really limited. And it's temperature limited is what it is. Even if we have adequate moisture, we just don't get good productivity out of cool season grasses because photosynthesis becomes very inefficient as the temperature rises. And that's kind of where these summer annuals or other summer grasses can kind of fit in. They can fill in what we call that summer slump in forage production. And these could be a perennial grass like a native grass like switchgrass, or it could be a summer annual grass like a sorghum Sudan grass or a pearl millet, or it could be an introduced perennial grass like Bermuda grass. But all of those have what we call our warm season or C4 photosynthetic pathway. That's much more efficient at carrying out photosynthesis during the summer months. We're going to produce about twice as much dry matter per unit of water used during the summer compared to a cool season grass. That's really, really important for us because we generally have limited moisture during the summer and we have higher evaporation rates from the soil in the summertime. So taking that limited water resource and converting it into forage is really important. And our warm season grasses do it much more efficiently than our cool season grasses. In the past, when we talked about summer annual grasses, we would always say, our general recommendation, find a reasonably priced, locally available seed and focus on management. And there's no question that managing these annual grasses, whether it's cool or warm season annuals, is really, really important to get the most out of them. But some of the data that I'm about to show you really kind of calls into question this old recommendation of just choosing this locally available variety that's reasonably priced. There's been a lot of breeding work with the sorghum species, which include things like forage sorghum, sorghum Sudan grass, and Sudan grass hybrids in the last 10 years. And some of that work has resulted in varieties that are superior for both yield and digestibility. And we need to start thinking about what those varieties are and how we can incorporate those improved varieties into grazing systems. So we've been doing summer annual variety trials at the research station for a long time. And if you're wondering what that picture is, that's a plot seeder. It'll wear you out, but it's probably one of the best seeding methods. It's got a cultipacker in the front and kind of makes a V in the soil. The seed drops into that V. We've got a little chain that's behind it that drags a little soil on top of it. And then in the back is a press wheel. You can't quite see them. They're right in front of where Sandy's walking at. And press the seed and the soil into contact and just get a great stand. So we've been conducting these summer annual variety trials since the early 2000s and evaluating primarily yield. It wasn't until more recently we started to look at the digestibility of some of these improved summer annual varieties. And we've had sorghum Sudan grasses, pearl millets. In some cases, we've even had crabgrass in some of the trials over the years. Pretty standard nitrogen management. We put on 75 pounds of nitrogen at seeding and then 60 pounds after each harvest. And we manage these not under grazing, but under kind of a mechanical harvest. I'll show you some pictures in a little bit of how we did that. Pretty standard nitrogen management. We wanted to stimulate regrowth with that second shot of nitrogen after the harvest. And we did this for each harvest except for the last in the growing season. So this is from the first year that we measured digestibility. And this was in 2009. And this is the summer annual variety trial 2009. We had about 22 or 25 varieties in here. So that if I put all those on the slide, we couldn't read anything. So I picked 2 of the top yielding varieties, 2 of the middle yielding, and 2 of the low yielding varieties. And this was for the first harvest in 2009. And we had a forage sorghum in here, we had a sorghum Sudan grass, and we had a Sudan grass, and we had a pearl millet in here. All the sorghum varieties are related. All these species, they're a subspecies of sorghum. And they have some different characteristics. For example, the sorghum Sudan grass tends to be a finer stem than the sorghum Sudan or the forage sorghum, which tends to have the largest stem. Some had what we call the BMR trait. That's a brown midrib trait. That's a phenotypic or an outward expression of something that's different inside that plant. And what's different is it has lower levels of lignin. And Susan talked about that earlier. Lignin is something that gives the plant structure, but it also makes that plant fiber indigestible in the rumen. So the higher levels of lignin, the less digestible that fiber is in the rumen of the animal. So some had this trait that had lower levels. When you have the BMR trait, you tend to have lower levels of lignin, and some did not. And this is kind of what that trait looks like. If you look at a sorghum leaf of a sorghum Sudan grass or a Sudan grass or a forage sorghum, it will have a brownish, or a tannish color to the midrib of that leaf. And that's an outward expression of that there's something different inside that plant. And that difference is those lower lignin levels. So when we looked at our first harvest yield, we were surprised at the range of the first harvest yield. 3,800 pounds to 6,800 pounds at that first harvest. So a pretty big range in yield. But what was even more interesting was the range in digestibility, 54% to 74% at that first harvest. And that's what we call in vitro true digestibility. That's when we take that forage material and we take rumen fluid out of the cow. So we've got cows that have big rubber plug in their side, and you pull that plug out and you get rumen fluid out, and you put that forage in that rumen fluid, and the microbes in that rumen fluid break that forage down, and we measure how digestible or what disappeared due to that microbial digestion. And that gives us a nice estimate of how the animal will do when it's grazing that forage. So we had a range of 54 to 74%. So a huge range in digestibility. And when I saw those numbers come back from the lab, I said, well, for sure, those varieties that had a low digestibility are going to be the highest yielding ones. Because generally as a plant matures, the digestibility tends to decrease like Jimmy showed in that picture. But when we started to match these numbers up, lo and behold, some of the most digestible varieties in the trial were also some of the highest yielding varieties in the trial. And that kind of really got me interested between this relationship between yield and digestibility. So over the next 10 years or so, we've been looking at this relationship, trying to figure out what varieties have this combination of high yield and high digestibility. This was kind of our data set. I'm going to show you 2, 4, 5 years of data today. And this shows how many entries were in each year of the trial. So we had somewhere between about 20 and 30 varieties, depending on the year. They were entered by private companies, and this was a paid trial. So sometimes they entered their variety every year. Sometimes they didn't enter it every year. This shows you how many varieties had the BMR gene and how many did not have the BMR gene. And then within the BMR trait, there's different places along the genetic code that it has the mutation. So we have what we call the gene 6, 12, and 18. By far the most popular place is the gene 6. And most of the commercially available varieties will be a gene 6. So this is the yep.
Did you come to the conclusion you had yield, you had the profitability or whatever you call it?
Yeah.
Did you have another figure that said which was best?
I do. We're getting to it.
Okay.
We're getting to it. That's what we're going to end with. That's the climax of my presentation. But anyways, this is a relationship between yield and digestibility, and this was in 2009. And what I wanted to show you here on the bottom, we have yield, dry matter yield. And so 2,000 to 10,000 pounds. And this was for the whole growing season. And then here we have in vitro true digestibility when we take that forage and put it in rumen fluid from the animal and measure how much of that forage was digested. There was no relationship. It's like a shotgun on there. So each one of those points represents a variety in that trial. So there was no relationship in 2009 between yield and digestibility. And that's really interesting because we thought there would be. In 2010, again, no relationship between yield and digestibility. Now, some years we did have that relationship, and in 2011 we had a negative relationship. So as yield increased, digestibility tended to decrease. And we had a negative relationship in 2012 between yield and digestibility. In 2014, a slight negative relationship. It wasn't quite as strong. And in 2015, I don't have that slide in here, we had no relationship again. So in summary, some years we had no relationship, 2009, 10, and 15. 2011, 12, and 14, we had a negative relationship or a slight negative relationship. We don't understand all the factors impacting this relationship. They could be environmental. It could have to do with the varieties that were entered in the trial in a particular year. But we don't understand exactly why we see a negative relationship in some years and not in other years. But what we do need to do is look for outliers. So we need to look for those varieties that have above average yield and above average digestibility. And that's kind of where we're going at with selecting summer annual varieties. So before I show you that data that you're looking for, I do want to mention the impact of the BMR trait on digestibility, and it was very consistent over the years. So this is 2009 to 2014. On average, we're about 5% higher in digestibility when we select a variety that has the BMR trait. And that's important. So if we just go and look at all the varieties that we had in the trials, ones that had the BMR trait were on average about 5% more digestible, and that's significant. So the point that I want to make with this is if you're going to use this, especially for lactating animals or animals that you want to get growth on, then you need to be selecting a summer annual variety, a sorghum species that has this BMR trait. Now, having said that, if we go here, and this shows the minimum and the maximum digestibility of the varieties within the BMR trait. So if we go to, say, 2009, we had the lowest digestibility was 61% and the highest was 76% within the BMR trait. These were both BMR varieties, but one was considerably more digestible than others. And the same thing happens over the years. About on average, 10% range in that digestibility. What's that tell us? That tells us that simply buying a bag of BMR seed is probably not good enough. We need to be looking at digestibility on an individual variety basis in making our selections that way. Because there is a considerable amount of range even within a BMR trait within a given year. For example, here's 9% here, and so on. So we get these data sheets, and I've got these data sheets. Do you have a question, or are you just, okay. So I have these data sheets, and some of these data sheets have thousands of data points in them, and I hand them to people, and they look at them one time, and they say, wow, that's nice. and that's the last time they ever look at them. So one of my goals was trying to figure out how I can get people to see this data so that they can make variety selections. And what we came up with was this graph. And what this is a graph of yield and digestibility difference. So 0 on my graph is the average yield for this particular year. This is the average yield for the trial. And what this does is it lets us rank all the varieties either above average in yield or below average in yield. And we did the same thing for digestibility on this, the in vitro true digestibility. 0 on this graph is the average digestibility for the trial. So all the varieties were either above average in digestibility or below average in digestibility. Exactly. You're one step ahead of me. You're one step ahead of me. Sometimes it's as important to know what not to plant. And yeah. That's a great question. We're going to show some data on the next page. And with variety testing, you're not going to have a variety that does perfect every year, but what you want to look at is start to look at a range of years and look for varieties that have above average yield and digestibility for multiple years in a row. And we're going to look at that in the next slide. So these varieties down here in the bottom left-hand corner, as this young lady pointed out, these are ones that we don't want to use. They have below average yield and below average digestibility. We want to avoid varieties in this part of the graph to put into our forage programs. This is the corner that we want to look at again. We want to see these varieties that have above average yield and above average digestibility. And as Susan pointed out, we want to look for varieties that are there for more than 1 year. We want varieties that have performed well above average for yield and digestibility for multiple years. So each year of the trial I went through and I listed the varieties that did well in that particular year. And I've got graphs like these for every year of the trial. And then we came in and this is kind of a summary sheet. And I think this is what you were looking for. So these are varieties that had above average yield and digestibility for at least 1 year. And I've got the years listed here. And then we put an X where they had above average yield and digestibility. What we want to look for, as Susan pointed out, was these varieties that have more than 1 year of above average yield and digestibility. They won't be above average every year of the trial. That just probably doesn't happen. But when we start to see 3 or 4 years out of, say, 6 or 7 years that these varieties have above average yield and digestibility, then we need to start taking a second look. These are ones that we would want to consider putting into a forage program that have that consistent performance. Whenever we use variety trial data, you never want to use 1 year of data. You want to use multiple years of data in ideally multiple locations within the state. Because what that tells us is that the varieties that we're choosing are robust across different conditions within the state and across different environments. So those are the ones that have multiple years of above average yield and digestibility that we may want to consider putting into a forage program. The take-home point today is that when we select these summer annual varieties, we need to look at more than just yield. We need to start looking at digestibility, and we probably need to start looking at other forage species also for digestibility. I suspect even within our cool season grasses, we're going to see a range of digestibility within those cool season grasses. So we need to start thinking about past yield and thinking about how animals perform on these different varieties. So now what I want to talk a little bit about is where do these summer annuals fit into forage systems? And in one place that I think they could be a good fit, especially for Western Kentucky, is in weaning systems for fall-born calves. You know, we calve in the fall for a number of reasons, but one is that we can try to get those animals rebred during a cooler time of the year. A lot of times when we spring calve, we get into June and it's starting to get pretty hot and we have problems getting those animals rebred. Also, stockpiled tall fescue within the grazing system is a good thing to utilize in the fall. It's very high in nutritional value and fits well into a fall calving system. So calves are born in November and we wean them sometime around June. In the south side of Virginia where I was at, we had a program with our cattle association where we gathered calves up and we put them on a backgrounding ration. It was a commodity pellet and then free choice hay. It cost about $2.25 a day, and they gained about 2¼ pounds a day. Some years 2¼ some years less, depending on the environmental conditions. When it was real hot, we would have depressed gains, as you would expect. Summer annuals may be able to do this, but at a much more economic cost compared to this ration of $2.25 a day. So a summer annual weaning system would look like this. We would plant the summer annuals, and as soon as our soil temperature got up to 60 degrees, and they'd be ready to graze in mid-June. The cost of production and utilization can vary, but it's going to be about $150 to $200 per acre to plant those summer annuals. And that seems like a lot of money, but when we start to look at net return from these summer annuals, they're pretty cost effective. That's my economist cost. So that's not a farmer cost, that's my economist cost, and they put everything in that except for the kitchen sink. They've got interest on this and interest on that, and those are real costs. Don't get me wrong, those are real costs, but everything is figured into that. And I'm going to show you a sensitivity analysis in a minute which varies the production cost, so you can see how that impacts how much it costs per day to graze those calves. But I would say $150 is a reasonable cost. It's got seed, fertilizer, planting, equipment costs, and a little bit of labor, and then interest costs and some miscellaneous costs. Okay, so what I did to kind of come up with a mean production, or how productive these summer annuals were, is I took data from 2004 to 2015 that we generated at the research station, and we looked at the minimum yield, the maximum yield, the median yield, and mean yield, which are about the same thing. And then we calculated the number of grazing days, and then we calculated the cost per grazing day. And really what I want to focus on is not all the variation, because there is variation between years. Some years, like this year, was extremely high. We had some extremely high yields this year, and I'm not sure exactly why, but we just did. We want to look at the long-term average, and the long-term average, if we look at the mean yield, is somewhere around 6,800 pounds of dry matter being produced long-term. And the cost was about 88 cents per grazing day on average, and the number of grazing days per acre were 226. So that means I could graze, and you would never do this, but you could graze 226 calves for one day or one calf for 226 days. We'd never do that. We'd be somewhere, in the middle there. But so let's do some calculations. I rounded the numbers off. Remember, I said 6,800 pounds of dry matter. I just said 6,500 pounds average production over that 10-year period. We set a utilization rate of 50%. So that means when I turn those animals into that field, if I've got 10,000 pounds of dry matter there, they're going to eat 5,000 pounds. We're actually going to get in the stomach of the animal. The other 5,000 pounds will be wasted and will be residual, and they'll lay down and walk over it and so forth. And that could be higher depending on how you manage your grazing, but 50%, is a kind of a conservative estimate. So that means if of that 6,500 pounds, we're going to have 3,250 that actually gets in the stomach of the animal. So then we calculated our grazing days per acre. So we take that 3,250 and we divide it by 15 pounds of dry matter per calf per day, and we're going to be working with a 500-pound stocker calf. And it's going to eat, I think I figured, what percentage is that, Kelly, real quick? 2.5 or 3% of its body weight. But that calf's going to eat about 15 pounds a day, so we take 3,250 divided by 15 pounds a day, and that gives us 215 grazing days per acre. So if we looked at the cost per grazing day, and I used the high end of the estimate, so I said 150, I used $200 per acre. divide it by 215 grazing days per acre, and we came up with about 93 cents a grazing day. So that's about $1 a grazing day. Remember, what did it cost us to background those calves on a pellet and hay? $2.25. So this is less than half the cost using average production. Remember, what makes up an average? The good and the bad. My economist in Virginia would say, on average, sticking 1 foot in a bucket of ice cold water and 1 foot in a bucket of scalding hot water, on average feels pretty good, but it hurts like hell. So the other part of this economic analysis is trying to figure out what kind of production you're going to have off of these stocker calves on summer annuals. And we didn't have good data for Virginia, so I used some data. It was 5 years of data, or 4 years of data from Texas, and they do a lot of summer annual grazing in Texas. And when we looked at the range of production, these are different summer annuals on the top here, different varieties. And when we looked at the average production, it ranged from about 2.25 to 2.84 pounds of average daily gain per day on these stocker calves. This was the average, but for my calculations, I'm going to use the least amount they gained in the trial, which was 2.25 pounds a day. And I think that's reasonable. I think we'll see gains in western Kentucky in the range of 2 pounds a day. We're going to find out in the next several years. So let's look at the return for backgrounding these calves for 60 days on these summer annuals. We're going to assume 2.25 pounds a day. We have to assume some prices. So what I used was the average 10-year price of calves, and I did this for Virginia because I had all that data already. But this was looking from our Department of Agriculture, keeps track of these numbers. Medium and large 1 calves, 500 pounds sold. If we sell them in June at weaning, we're $1.59 a pound over a 10-year period. If we look at medium and large 1 calves, 650 pounds, because remember, if we keep these calves for 45 days, they're going to gain 150 pounds. It was $1.45. Those two numbers are important because when we market a calf later in the year that's heavier, we're going to get a slide, and that slide was 14 cents in price. And that's a real price, and this is over a 10-year period. Some years it's more than others. There's no way to predict it perfectly. But over a 10-year period, we had a 14-cent slide. So if we assume 215 grazing days that we calculated earlier, and we're going to assume that our cost per grazing day is 93 cents. And we're going to assume good agronomic and grazing practices. And I can't stress this enough. If you make the decision to plant summer annuals, you've got to fertilize them. There's no free lunch. It hurts my heart to drive across the countryside and see a nice stand of summer annuals that are just begging for a little bit of nitrogen. You know, you've got to fertilize those and you've got to manage them and do a good job grazing with your grazing practices also. So let's do some calculations. If we took that calf at weaning, 500 pounds, and we sold it when we weaned it, then the gross return would be $795 per calf. If we sold those calves after backgrounding for 60 days, that calf's going to weigh more, right? Because it gained 225 a day, but it's going to be less per pound. But the calf is going to be worth $921. And those are before we take out fees for yardage fees for the stockyard and hauling costs and so forth. So if I was a good economist, I would have taken all those out. But I'm not. I'm an agronomist. So if we look at the difference between those two values, it's $126 per calf. So in 60 days, the value of that calf has increased to $126. Not really, because we haven't taken out what it cost us to produce that calf, which was $56. That's kind of our gross return. Our net return would be that $126 minus what it cost us to put that weight on in that 60 days, which was $56. So that gives us a net return of $70 per calf. Or if we convert that into acreage, we're stocking at about 3.6 calves per acre. That's going to be $250 net return per acre for backgrounding those calves for 60 days. Just take a minute and think about that. what can we do in agriculture that's going to give us a net return of $200 an acre in 60 days? Not a lot of things. We can add some real value. I mean, this is an opportunity for us. We can add value to these calves. What's important to remember is that whenever we do an economic analysis, it's important to remember that economic outcomes are sensitive to both changes in what it costs us to do and then what the sale price of that is. So what our input is and what our sale price is. And that's kind of what this spreadsheet shows. And you can actually go to this link and download this spreadsheet from here. And it's an interactive spreadsheet, and it'll let you put your own numbers in and calculate your net return to what I call land, labor, and risk. So that's if you have to rent that land, that's not included in this. It's to land, labor, and risk. And I don't include anything for your labor, so that's included in this. And then the risk, of course, if you have enough calves, you're going to lose a calf every now and then. Okay, so what we have on this is a calf price at weaning. So when I sell that calf at weaning, so when I wean that calf, I had a price range from $1 to $2.50. We'd love it if our price was always at $2.50 a pound, but it's not. It's going to be somewhere in the $1.50 range over a 10-year period. But this gives you the ability to look at how calf price will affect your net return per acre. And then I changed on the top the cost of doing the summer annuals. So $100 to produce a summer annual per acre up to $200. And this is the extremes. Probably you're going to be in here in the middle, if you're honest with yourself, somewhere about $140 or $150. So what we want to look at is where our calf price is now. You know, if we look at $1.20 or $1.30 and we have a reasonable cost of production, our net return per calf, this is net return per calf, dollars per calf, after our production costs are taken out is $62. So multiply that by 3.6. I can't do it in my head, but it's going to be about $200 an acre, even at the current market price. Net return. And this gives us our grazing costs, dollars per calf per day, 65 cents at $140. And the neat thing about this spreadsheet is you can vary the weight of the calf, starting weight of the calf. You can vary your average daily gain. If, say, you were more conservative and you only wanted to put in 1 3/4 pounds a day, just change it in that spreadsheet cell, and it changes everything in this spreadsheet. Your grazing period, say you want to keep them for 70 instead of 60 days or 50 instead of 60 days, you can vary that. And then your summer annual productivity. So that's the number of grazing days per acre. You can change that up or down. And I put limits on those that are reasonable because I don't want people using this spreadsheet and putting in something that's completely unreasonable. So if it won't let you put it in, it's because it's not a reasonable assumption to make. All right. And that's a tool, and I would encourage you, if you're thinking about this, go home and download that spreadsheet, and you can mess around with it and take a look at how this might fit into your system.
I think this looks like I'm a cow-calf guy. I'm not really much of a size stock of calves and bring them all in, folks and everything to everybody. What does this look like if you're full grazing, street grazing versus dry feed? Same numbers, or how much difference is it?
I think you'll definitely get a benefit, but I don't know the answer to that completely. And one of the issues would be getting the stocking density high enough to efficiently use these summer annuals with creep grazing. I mean, you could graze both the cows and the calves, and I think that'll be beneficial to help you put conditioning back on the cows after winter if you need it. I would say it'd be most efficient in a weaning system. So when you wean those calves, to put them on some summer annuals for 60 days, increase the weight, and then sell them.
Think it'd be more in spring herd versus fall herd?
I think you could do the same scenario. Well, I think it would work better with fall calving cows because those calves are ready to be weaned in June when these are really becoming productive, the summer annuals. But you could almost do the same scenario with cool season annuals in the fall. if you did a good job getting your cool season annuals in early, and then as you weaned those fall-born calves, having something really high quality to wean them onto. All right, and Jimmy kind of talked about this, but I think summer annuals and winter annuals also have a real place as a component of a pasture renovation cycle. And I think there's a tremendous amount of missed opportunities from not including new forage genetics into grazing systems. We've kind of settled on Kentucky 31, and people don't want to move off of it, but there's a lot better varieties out there than Kentucky 31, and these novel endophytes are a tremendous example of that. And this is just some data, and this was from a publication by Craig Roberts and John Andre, Fescue, Toxicosis, and Management. And they summarize some data, but these novel endophytes are real. So here, for example, in Fayette, Arkansas, they had on toxic tall fescue, average daily gain on stocker calves of 0.9 pounds a day versus 1.4 pounds a day on a novel endophyte. And that's consistent across all these trials. Sometimes it's more than that. But the point is this is something that we need to be thinking about incorporating into grazing systems. And these annuals give us the ability to, or the vehicle to get these improved varieties into grazing systems. It doesn't have to be novel endophyte tall fescue. It could be alfalfa or an improved orchard grass or whatever you decide you want to put into your system. So endophyte-free fescue, so you have essentially three choices. You have the toxic endophyte, endophyte-free seed, and novel endophyte tall fescue. Tall fescue has formed a symbiotic or a mutualistic relationship with the endophyte. And in that relationship, the endophyte, which is a fungus that lives between the plant cells, gets a place to live, and it gets a carbon source or an energy source from that tall fescue plant. And in exchange for that, it gives the plant tolerance to stresses. So tolerance to overgrazing, tolerance to insects, tolerance to drought, and so forth. So essentially what having the endophyte in the plant does is make that plant hardier or more robust. One of the negative things it does is it produces a class of toxins called the ergodalkaloids, and the ergodalkaloids reduce animal performance. It causes vascular constriction in the animal, and because of that constriction, the blood can't flow to the outside tissues, and the animal can't cool itself in the summertime. So a lot of times even when it's 50 degrees out or 60 degrees out, we'll see animals standing around in ponds, and you're saying, what in the world's going on? Well, it can't regulate its body temperature because of these ergodalkaloids. So that reduces animal performance, and for us, the biggest impact is on conception rates. We can have really low conception rates in cow-calf herds in states like Kentucky, where we are a cow-calf state, but also lower performance in stocker calves. So we kind of finally figured that problem out. So we released tall fescue in the 1940s. By the 1970s, we figured out that we had some kind of a problem, and then we figured out that it was this endophyte. So, as researchers do, they said, well, let's just take the endophyte out. So they took the endophyte out of the plant, put some animals on it. Animal performance was great. They said, problem solved. Go ahead and everybody replant your pastures to endophyte-free tall fescue. And people did. And what they didn't figure out is when they took the endophyte out, they also took that robustness away from the plant. So it didn't persist as well under continuous stocking like Kentucky 31 would persist. And a lot of people planted endophyte-free, and they lost the stands and because they weren't properly managed. So you can use endophyte-free, but you really have to be on top of grazing management to make it persist. So the next chapter in the tall fescue story was the development of novel endophyte. So that's an endophyte that gives that plant hardiness and persistence, but doesn't cause animal-associated problems. So animal performance is the same as endophyte-free, and persistence is better than endophyte-free. And that's kind of the difference between those three. So what should you use? The best choice will be a novel endophyte tall fescue because it's got improved persistence and tolerance to stresses, but it also has good animal performance. Is it perfect? No, it's got to be managed better than Kentucky 31. Because what doesn't happen is when animals graze Kentucky 31 in the summertime, they feel bad. They get sick. And because they're running a low-grade fever, essentially, because they can't cool themselves. And so that's negative feedback for that animal. So the animals don't graze that pasture as hard because they don't feel good. And with a novel endophyte, that negative feedback is not there. So even though the plant's hardier, animals will tend to eat more of it, especially during the summertime. And that puts a lot of stress on that stand. So we have to have improved grazing management during the summer months. We have to be rotationally stocking those novel endophyte pastures for it to really be persistent within that grazing system. And that's really, really important to realize. Is that good, Daryl? Probably more than you wanted. So just a renovation cycle. So as you go around the farm, you don't want your whole farm in annuals by any means. You want a good perennial sod. You want to identify pastures in need of renovation. You can spray out with a selective, non-selective herbicide like glyphosate in summer or early fall. Come in with the winter annual mixes like we looked at out there. Graze or harvest those winter annual mixes and then come back with the summer annual mix in the spring. Graze or harvest your summer annuals and then spray if needed. If there's any tall fescue escapes within there, spray one more time, and then you can come back into a novel endophyte tall fescue or another improved forage species. And by doing this on a small portion of the farm, you can move that renovation around the farm and always put improved forages in your grazing system. Plus get the benefits of using these cool and warm season annuals in your grazing system. Okay, and there's a shareable link on my Google Drive page, which I think is still working. This is from Virginia. I need to make a Google Drive for here, I guess. This is the link to those spreadsheets on there. And there's a copy of this presentation on the Google Drive also. The last one I want to talk about, and we kind of talked about this in the field already, so I won't belabor it, but when we look at crabgrass, it's well adapted to places like Kentucky. It is a true warm season annual, just like we were talking about. It has to come back from seed every year, but it reseeds itself, as we saw in the field. There's just thousands of seed produced on that, tens of thousands of seed produced per crabgrass plant. Again, it's not productive during the winter, so we really need to double crop it with a winter annual like we were looking at today. It has good yield potential, but where it really excels at is forage quality. Much higher forage quality than a perennial grass like Bermuda grass would be within a grazing system. No prussic acid, that's one issue that you can have with the sorghum species, and we can talk more about that later if you'd like to. Under extreme rates of nitrogen fertilization, it can accumulate some nitrogen rates. That's crabgrass in 2001, 60 days after planting. That's a forage harvester, so we were taking yield estimates off this crabgrass. Instead of clipping quadrats, we cut a 5-foot swath through the center of each plot. It takes the forage up, dumps it into this, there's an aluminum bucket in here kind of, and the bucket has weigh cells on it, and we get a weight for this plot of how much forage was produced. But what I want to show you, this is an improved crabgrass species. This is Red River crabgrass, selected for upright growth. It was probably about this tall when we harvested this forage plant. Is this ideal for hay? Probably the ideal use would be grazing, and we wouldn't want it to get that tall for grazing. We'd want it to be about somewhere 10 to 12 inches tall when we started to graze it. We did a lot of different work over the years, but I wanted to show you this graph. This is response to nitrogen rate, so this is increasing nitrogen rate on the bottom, and this is the response to the dry matter yield on the y-axis. So essentially, as this plant, as we add more nitrogen, the yield of the plant increases, and it increases up to 305 pounds of nitrogen per acre. Don't ever put 305 pounds of nitrogen on crabgrass. You want to be down here on the straight part of this curve. So you want to be down what we use rates for traditional summer annuals, somewhere in that a total nitrogen rate of somewhere between 100 and 150 pounds of nitrogen applied as split applications of nitrogen. But the point I want you to take home is that we do get a nitrogen response in crabgrass. So putting a little nitrogen on can really stimulate yield. So I put nitrogen on at seeding, and then probably again in June. So a two split. Two applications. The first one I would go a little bit more, probably 60 to 70 pounds on the first one, and then come back with somewhere between 40 and 50 pounds on the second. 40 to 50 pounds to stimulate additional growth. We also did some work, I'm not showing it, but we mixed crabgrass and annual lespedeza, and that's a nice mixture too. Those annual lespedeza is a warm season annual legume, and it mixes real well with crabgrass. They have kind of the same growth cycle. 10 to 15 pounds of annual lespedeza along with the crabgrass. It's the same as we used Korean lespedeza when we did the study. So there's two types of annual lespedeza, Kobe and Korean. Generally speaking, Korean is going to be a little bit higher yielding than Kobe type lespedeza and has a little better chance of reseeding itself, although it doesn't do it consistently.
So if your pastures are overgrazed, right, so, start your late spring, whatever rotation, you're doing small lots, right? So if you overgraze, you bring the cows into a lot, move them out. What about planting, drilling in crabgrass and letting that overgraze down?
Yeah, that certainly can work, and we say in the south side of Virginia where I was at, if it wasn't for crabgrass and what we call Bermuda grass, wiregrass, wasn't for crabgrass and wiregrass, we'd have a lot of hungry cows in the summertime. And there's a lot of truth to that, because exactly what you're describing. So his question was, what about putting crabgrass in overgrazed pastures? That happens naturally in many cases. You'll see a lot of crabgrass in tall fescue pastures that have been overgrazed and that sod's been weakened. So that's a real option. R.L. Dalrymple says that for crabgrass to grow in, say, a tall fescue sod, it needs about a 6-inch space in that sod. And so crabgrass is what I call a species of opportunity. It needs that open space to grow. You're not going to find it in a strong, tall fescue stand. There's no space for it. You got to have about a 6-inch open spot for that crabgrass to germinate, come up, and make a plant and be a part of that stand. So a thin stand, you could definitely overseed with crabgrass and annual lespedeza. So forage quality, we did some work, and we had 75 to 90% digestibility with this, very high digestibility with this crabgrass in a vegetative state. Crude protein in season was 10 to 14%. At the end of the season, when the crabgrass was kind of getting brown and dying, it was 6 to 8%. And we saw an increase in, as Ernest talked about, an increase in crude protein with nitrogen fertilization, and that's not uncommon with warm season grasses. We'll tend to have a bump the crude protein up as we increase nitrogen fertilization. But this is where the rubber really hits the road. And R.L. Dalrymple that Jimmy was talking about in the field has done a lot of crabgrass work over the years. He's retired now. But on medium quality crabgrass, he said you'll get an average daily gain. This was like 20 years of stalker calf data on a medium quality crabgrass of 1 pound and 8/10 a day, unsupplemented. So very good animal performance on crabgrass. Head to head with Bermuda grass, you're looking at 1 3/4 pounds with the crabgrass, 1 pound with Bermuda grass. So Bermuda grass is not a bad summer grass and fits well for cows, but for really high performing animals, you'll want crabgrass or some of these other summer annuals. And with that, I'm finished. Thanks for hanging with me. I know it's been a long day, but I certainly appreciate you all coming out. And Daryl has a few things to say. Is there any questions, Kevin?
He and
I didn't talk about prussic acid, but what prussic acid is it's essentially hydrogen cyanide, and it can be formed. It's in higher concentrations in regrowth from sorghum Sudan grass, and it's formed when the precursors are released from the plant cells during some kind of event that ruptures the plant cells. Usually when it's a problem is in the fall, is when it's a big problem, because we'll start to get frosts on sorghum Sudan. That'll cause the rupture of cells in hydrogen cyanide is formed in that plant. And if animals eat it at that time, it can be very toxic to the animal. I would say that the scare of prussic acid poisoning has probably been a really, really bad thing for the utilization of these summer annuals. I think it's a much bigger mental problem than it is an actual problem. As far as the regrowth, we tend to say avoid grazing regrowth of sorghum Sudan grass when it's below 18 inches. We want that plant to be about 18 inches tall when we start to graze. That's when the precursors for prussic acid are diluted enough in that plant that it's not really going to be a problem. So I would say I don't think it's a big worry, Kevin. Not like we make it out to be.
You can take a test, and so you can get a positive reaction on the test. And we got into that last summer on part of Sudan, and when I'm working with producers, not my cows.
Right.
No air on the side of caution, and you had different types of regrowth in that field. And we aired on the side of caution, but what happened was it all got away from us.
Right.
We kind of handcuffed ourselves and being able to manage it.
Right.
That forward like we do that.
Yeah.
And I'm just wondering if we aired too much on the side of caution.
You probably did. You probably did. Now with the calves at the research station, we won't, if we graze some summer annuals this summer, we don't have to be quite as cautious. I mean, we want to be cautious, of course. We'll tell Aya Cook, our animal use committee, that, but I think it's much more of a mental problem for producers than a real problem. And the same way with, we just have to be careful with prussic acid. I'd say the biggest time of the year to really be careful is in the fall when we start to get these freezing events. Same way with Johnson grass. Johnson grass is a sorghum species also, and you can get prussic acid poisoning mostly in the fall. So.
I had prussic acid written down, but also what about nitrates? How often are we concerned about those?
So,
At this point, you get a field ready, jacked up on nitrogen, and it turns off into drought.
So that's a great question, Clint. So the nitrates are another potential issue with any plant can accumulate nitrates, but we tend to see most nitrates accumulated in summer grasses that have been heavily fertilized. So one way to minimize that risk is not to put too much fertilizer on at one time. And then if you get into a drought period, avoid grazing those pastures during the drought period. Now, after a drought-ending rain comes, if you wait 5 to 7 days, that plant will use those nitrates back up and convert them back into amino acids and protein. So 5 to 7 days after that plant starts to regrow, we should be clear of nitrates. But generally speaking, just manage around drought-stressed summer annuals, especially ones that have been fertilized heavily with nitrogen just prior to the drought. I wish it was a perfect world, but you always have these type of issues that you need to manage around. Is there any questions?
Did you say to start grazing Sudan grass at 18 inches or not?
At least 18 inches, yeah.
Is that really the same as gamma grass?
Gamma grass, you probably want it a little bit taller, so 2 feet or so. And you want to graze gamma grass down to 8 to 12 inches. Summer annuals, you want to leave a residual growth on 6 to 8 inches. And we always talk about that as if our cows are going to graze every plant in the pasture down to 6 inches. But it doesn't work like that. In the real world, you want about an average of 6 to 8 inches. Some plants will be taller, some plants will be shorter. All right, Daryl, do you want to finish this up?